All right. So in the like in last session, what we covered up, like what is Docker, and mostly like how it is different, like how virtualization works, and then how there's Docker comes in picture. Okay. So like we saw a few of the benefits of Docker in last session. In this session, we will be going ahead. Okay. Yeah, we will be going ahead for how what is the Docker architecture. We will be focusing on Docker architecture completely. So this is the documentation I just have opened. Apart from that, we will see how it works and how all these things work. Okay. So till now we know like what containerization is. We will learn about containers in this session more. So first see what Docker is. Okay, how Docker architecture works. So Docker works on, if you see here, client. Let me copy this. Okay, so Docker works on this architecture. Okay, so this is client host architecture. So this host, this is our machine. Okay, this is our machine where Docker daemon is set up. While this client is nothing. Client is basically that Docker CLI. Okay, where we can run these commands: Docker build, Docker pull, Docker run, Docker network, Docker volume, all those commands. Okay, so basically in DevOps terminology, if you have ever heard about this client, so it means nothing, just a CLI. Okay, you can think it all as a CLI. So that in and for what purpose it is needed? For executing the commands over any server. Okay, so if you have Docker server, then Docker CLI is used for running the commands over Docker server. If you have Kubernetes, then kubectl is the CLI used for running the commands over running the calling the APIs over Kubernetes server. Okay, so if you see, we have Docker host here, we have client. So client, you are clear that this is kind of CLI. Okay, now coming to Docker host. Docker host, what Docker host contain is Docker in general, at the base level, Docker host contain this Docker daemon. Okay, so what Docker daemon is now? Docker daemon is the background service running. Okay, so background service means this is some service which is running in background. Okay, and it is running such that it will, whatever this CLI send the command. Okay, whatever this CLI command send, it will go to this daemon. Then daemon will execute whatever we have specified here. So it is like of CLI. Okay, CLI. Sorry. So it is like CLI call our daemon, and then daemon run our command whatever we provide in the command. Okay, so if I explain it more, so it is like you are the user here. Okay, you are the user, you went inside your command line, you ran some Docker command. Okay, Docker command, anything like ps, images, volume, anything. Okay, etc. Now once you type this command, so there will be one Docker CLI in your terminal, in your command prompt, in your CLI. Okay, so one Docker package is there. So I can say this Docker package, what it will do, it will see like in this Docker package, for these commands, like if we run ps, if we run image, if we run volume, there will be set of APIs defined which get hit for Docker daemon. So it will hit that specific API inside Docker daemon. So if we run Docker build image, okay, Docker or Docker run or Docker build, okay. So there will be some API for building the image here, Docker daemon, or some API for running the container here in the Docker daemon. So here from user, from the engineer, from engineer it will come in the form of command. This command will get converted inside the Docker daemon, like inside the Docker CLI. It will send to the Docker daemon in the form of API call, and once that API is called, Docker daemon will create that resource. Okay, so it will create a container, or else it will build a image, or delete image, build delete container, or create volume, or anything. Okay, so it is like we ran the command, we ran, see why we are running, because it is easy to learn the command rather than knowing how to, like, setting up this whole setup process and then calling the APIs. Okay, that's why we set up this Docker daemon such that, sorry, we set up this Docker CLI so that we will be able to like, where is that architecture? Okay, so that we will be able to call APIs inside Docker daemon easily. So we have this client. Okay, in this client we are calling Docker build. So when it reaches Docker daemon, it won't be in the form of Docker build. It will be in the form of some API for building the container. So these are the commands which we will discuss later on. But in general, these are the commands for Docker. Now, if you see here, images. Okay, so inside that Docker daemon, these images, these containers exist. So these are like, these gets created when we run these commands. Initially, as I run docker ps command in my system, so if I do docker ps, nothing is there. Okay, if I do docker ps hyphen a, stopped containers are there. Okay, so if you see stopped containers, so ps hyphen a is for stopped containers, ps is for running containers. If I do docker images, so we have lot of images as well. So if you go there, so these are the these are the part of docker hood. Now registry, registry is like storage. Okay, storage for our images. Okay, so there is one registry like docker up, that is the official registry of docker. We have in AWS, we have ECR. In uh, Google Cloud, we have GCR. In uh, Azure, we have ACR. So it is like EKS means, ECR means Elastic Container Registry for AWS, because AWS usually provide those elastic name. For Google, for GCP, it is Google Container Registry. For Azure, it is Azure Container Registry. Okay, so those are the registries. Those are specific to cloud, irrespective of the purpose. So all these three are used for same purpose. That is for images, for the storing the images. If you see, yesterday I saw that example of Ubuntu image. Okay, so this is one among them. So we would have this OpenStack, we would have this Nginx image there. So these all images, like we have lot of millions of images there on the Docker hub. Okay, so this was about the architecture. Now, are you clear about these things or not?
Yeah, well, okay, yeah.
Okay, now it comes to the most important part, that is containers and images. Okay, so what containers are, what images are. So let me clear this. Okay, so yesterday we saw that it works at the like OS level, and then we have containers at that level. Okay, so we have those app lives there inside container, we have OS inside that container as well, and we have our application. Like these are the libraries, I can say libraries, and this is the whole app. So this is, so basically if we see container in this form, so container is isolated environment. We can say it as an isolated environment which just need Docker daemon, or we can say Docker engine to be running. Okay, so Docker engine, inside Docker engine we have this Docker daemon. That's why we can say Docker engine running. If Docker engine is there, then it means Docker daemon is there as well. Okay, so you don't need anything else. If you have any operating system over which Docker engine is running, then you can run the container. Now what is container? Container is running form of image. Okay, so image is kind of static thing which is not running, which is not like running. You understand the meaning of running, right? Which is not executing at moment. Okay, which is kind of static, residing in any storage, that is image. And then if we run that image, it becomes the container. Now what is the image? That is the biggest question. Okay. So uh, image is a package. Okay, image is a package of your application. Okay, whatever your application is, operating system, for which operating system you want, what operating system you want of your image, all the packages required to run the application, all the command defined as well, commands defined as well. Okay, so I think you would have, so yeah, don't confuse image with those pictures or the visible graphics. Okay, don't confuse image, Docker image with image. Image generally means this is image, this is image. Okay, this is some image, this is some image. Don't get confused with this. What Docker image is, it is a package. In that package, what we define at top level, we define the operating system, which operating system you want to use. Then you define the your packages, whatever packages. Like these all are not mandatory that you need it at first level or second level, but it is best to provide the operating system at the top. Like this is what I'm talking about, the Docker image. Okay, how to create a Docker image. So while creating a Docker image, we need to provide these things: OS, packages, how to like install these packages, your application code, the code of application which you want to run, then the commands to run this application code. Okay, so executable commands. Okay, so then you have to define executable commands. Now once we define this file which contain all these details, we call it as Docker file. Okay, this Docker file, once we run a Docker build command, it gets converted inside Docker image. It gets converted inside image. So image, how image gets created, we write Docker file. In that file we define all the things like OS, what package, application code, executable command, and lot of other things. We can discuss those in later. So once we execute this file, this Docker, so this, once we combine all these things, it become a Docker file. Docker file gets executed how? Via this Docker build command. And once this Docker build command runs successfully, then it creates a Docker image. Once you have this Docker image, then you can run it, and form a container. So as we define all the details here, now this image will have everything, right? Operating system, what OS to use, what are the packages, everything. Now when you run this container, you don't need to worry about the operating system. Why? Because operating system is defined here. You don't need to depend on the host OS. You don't need to depend on this. Okay, host OS is just used to for what? For running this Docker engine, not for this. Over host engine, your Docker engine is running, and then Docker engine is in managing all these things. So you don't need to worry for that. Just a moment, but I am getting a call.